In 1831, two physicists, Michael Faraday in England and Joseph Henry in the United States, independently discovered that magnetism could produce an electric current in a wire. Their discovery changed the world by making electricity so common that it would power industries by day and light up cities at night. What Faraday and Henry discovered was a technique where no battery or other voltage source was needed to produce a current, only the motion of a magnet in a wire loop or coil. Production of voltage depends only on the relative motion of the conductor with respect to the magnetic field. Voltage is induced whether the magnetic field moves past a conductor or the conductor moves through a magnetic field. The amount of voltage induced depends on how quickly the magnetic field lines are crossed by the wire. Very slow motion produces hardly any voltage at all. Quick motion induces a greater voltage. Increasing the number of loops of wire that move in the magnetic field increases the induced voltage and the current in the wire. Pushing a magnet into twice as many loops will induce twice as much voltage. For a coil with 3 times as many loops, 3 times as much voltage is induced. We don't get something, energy, for nothing by simply increasing the number of loops in a coil of wire. Work is done because the induced current in the loop creates a magnetic field that repels the approaching magnet. Work must be done to move the magnet. When the bar magnet is pulled away, the induced current is in the opposite direction and a magnetic field attracts the bar magnet. Inducing voltage by changing the magnetic field around a conductor is called electromagnetic induction. Faraday's law describes the relationship between induced voltage and the rate of change of a magnetic field. The induced voltage in a coil is proportional to the product of the number of loops, the cross-sectional area of each loop, and the rate at which the magnetic field changes within those loops. The current produced by electromagnetic induction depends upon the induced voltage, the resistance of the coil, and the circuit to which it's connected. For example, you can plunge a magnet in and out of a closed rubber loop and in and out of a closed loop of copper. The voltage induced in each is the same, but the current is quite different. A lot in the copper, but almost none in the rubber.